Hello everyone, welcome to the YouTube channel of TriboNet. My name is Manoj. Today in this video, let us learn about dispersants for lubricants. Dispersants are like the detergents that are used in fuels and lubricants for many years to prevent excessive viscosity in the automobile lubricants. By keeping polar debris from oxidation in suspension, dispersants prevented thickening. Today, they are widely used in various automotive fluids, including engine oils, fuels, transmission fluids, and gear oils. They help in preventing oil thickening, ensures the consistent flow properties, and optimal lubrication. Further, they contain carbon sludge, preventing blockages that could restrict oil flow and cause engine failure. The need for dispersants. Without dispersants, the lubricants could not maintain engine cleanliness and performance because they prevent sludge and deposit formation by keeping contaminants suspended in the oil. In the absence of dispersants, the lubricants can accumulate on piston rings and grooves, leading to ring sticking and loss of oil control. Further, the increased oil flow into the combustion chamber, causing higher engine exhaust emissions, also leads to greater oil consumption, requiring more frequent top-ups between oil changes. It causes valve deposits that cause sticking, leading to incomplete combustion and the additional emissions. It accelerates the oil degradation and necessitates more frequent oil changes due to the contaminants entering the crankcase. What are the mechanisms of dispersants? How do they work? Oil dispersants are primarily composed of surfactants dissolved in solvents. Surfactants are molecules with two distinct ends. One is hydrophilic, that is water attracting, and another is lipophilic, oil attracting. This unique structure allows them to interact with both oil and water phases. When dispersants are applied to an oil slick on the surface of the water, the surfactant molecules begin to interact with the oil water surface. The lipophilic oil attacking ends of the surfactant molecules attach to the oil, while the hydrophilic, that is water attacking ends, face the water phase. The presence of the surfactants reduces the surface tension between the oil and water, making it easier for the oil to break up and disperse into smaller droplets. This reduction in the interfacial tension allows the oil to mix more readily with the water. With the natural agitation from waves or other forces, the oil slick begins to break apart. The oil dispersant helps break the oil into small discrete droplets, typically ranging from 1 to 70 microns in size. This droplets forms and remain suspended in the top of 5 to 10 meters of the water column. Once the droplets are formed, the surfactant molecules absorb onto the surface of each droplet. The hydrophilic end of the surfactant faces outward toward the water, while the lipophilic end remains and embedded in the oil. This stabilizes the droplets, preventing them from recoalescing or reforming on an oil slick. The stabilized oil droplets are dispersed throughout the water column where they are diluted. Over time, the dispersed oil in the droplets is broken down and degraded by microorganisms naturally present in the water, helping to mitigate the environmental impact of the oil spill. What are the differences between dispersants and detergents? Composition. Detergents contain metals like calcium, magnesium, sodium, barium in the hydrophilic head. Dispersants do not contain metals, may contain amine structures. Acid neutralization. Detergents can neutralize oxidation products, while dispersants little to no acid neutralizing. Effect on combustion. May leave an ash residue upon the combustion. Calcium carbonate is often used to reduce the ash. In dispersants, they do not leave any ash residue, focuses on suspending contaminants. Molecular weight. Detergents have a lower molecular weight and smaller molecules, whereas the dispersants have the higher molecular weight, which is 10 times larger, with the polymeric dispersants ranging from 1000 to 2000 and dispersant polymers over 25,000. Primary function: neutralize acids, remove deposits, and prevent the acid buildup, whereas dispersants keeps the contaminants suspended, prevent the formation of the larger aggregates. The role in the lubricants: detergents work with the dispersants to keep the contaminants in the suspension and prevent deposits, while as dispersants prevent the formation of the deposits by suspending contaminants. The use in engine oils neutralize acids to prevent the deposits but can leave ash. Keep the oil clean by suspending contaminants, ensuring the oil remains effective. These are the references for the information provided in this video. In this video, we understood what is the introduction to the dispersants, the need for dispersants, and the mechanism of how the dispersants work, and the difference between dispersants and detergents. Thank you for watching this video, and to get more details on the topics related to tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel TriboNet. Also visit our website on www.tribonet.org.